So we started example 2 by drawing a picture, and now we're going to find b sine of a to figure out the shortest possible distance. Straight on down. And it is how much? 5.9, I've been told. Is 8, this other side, in between those two? No, it is bigger than both, but it is at least long enough to make it down to the other side, correct? It is at least bigger than 5.9. Obviously, if it's not 5.9, it doesn't make it. So there are no solutions. But it is definitely long enough, which means it has to go over here. Because if I try and put it right here, it's too long. No, I said if it's not 5.9, it doesn't make it. That's what I said. But it is plenty long enough. It is 8. So can I draw that other triangle like I did in the first example? No. So how many solutions? 1. So do you have to worry about this whole quadrant 1, quadrant 2 thing if there's only one answer? No, you don't. You just go ahead, let law of sines do the job it's supposed to, which says to take sine of 57, whoop, that's a 7, over 8 equals sine of b over 7. Because again, that's a, b, c. Well, the answer would be one solution if we were on Friday's notes, but we are on Monday's notes. And so we have to actually go find them now. Are we expecting angle B to be more than 57 or less? So go ahead and solve it now, please. It should be review how to do that. Does anybody have angle B? 47 point what? 2? 47.2. Do I have to go look for that other option? No, it's not going to happen. So I can just go get angle C quite easily now. We've got 57, we got 47.2. So we really haven't used up that much yet. There's still quite a bit out there, right? And how much? 75.8, okay. Has the triangle been solved? No. Side C is what would remain. And so I normally just go right back to the pair like I told you before. Yeah, we would do sine of 75.8 over C. And no arc sine needed this time, so that sometimes makes it a little bit easier for people. And how about as far as sides go? Is this going to be medium, the biggest, the smallest? It's got to be the biggest because it's the biggest angle. And so if you get something like 5, you know that's not right. But I would be concerned if you got something like 30 as well. It's a little big. I've heard 9.2 several times, and it is correct. No need to go look for the other answer because it wasn't between B and B sine A. Do you have any questions about this one? No? All right. The last one is obtuse, which has different rules. It's only when it's acute do you have to worry about B sine A. I think some of us maybe had forgotten that on Friday. So this side is 13. The other side is supposedly 15. So does that have a shot of making it? Is it long enough? Yeah, it is, because across from the obtuse has to be the biggest side. And so if angle A is 100 and side A is the biggest side out there, it has a shot and it will connect. Now what if the 13 and 15 were flip-flopped where they were? If the 13 and 15 got flip-flopped, it would have no shot. But remember, our problem with law of sines is that we could have 2 possible answers. Our problem with law of sines is a first quadrant, second quadrant problem. Can I have a second quadrant angle in this triangle? 100's already been used up. There's not enough room for an obtuse. So you don't have to worry about that other case. You can just go ahead and do law of sines. And you could go ahead and finish that right now, but I think what we're going to do instead is what I did last hour, which I think was the most helpful. Again, you could sit here and solve this one, or I could just tell you the answer. Because I think most of you could solve this one, it's just straight away. Angle B ends up being 58.6. Angle C then is 21.4, and side C is 5.6. So if you would like on your own to get to those answers, that's fine. But we're going to actually go and create a two-solution problem and do it. So on the back, we're going to do this. All right. We're going to make an angle here, and we're going to make it, oh, I don't know, 65. Sounds pretty good. 65 degrees. So, in other words, angle A is 65 degrees. Side B, let's have somebody come up with a side B, 20. Okay. I'm not going to tell you side A yet. I'm going to make you figure out what side A has to be. But we know 20 would then go here. So what we would first do is figure out what is that shortest distance possible for this to actually make a triangle. And we do that by doing B sine A, which is 20 sine of 65. So figure that out. I've been told 18.1 for that. Do we agree?
Are you sure?
So, I want this to have two answers. So please raise your hand if you can tell me a possibility for side A that would guarantee two answers to this problem. 19.8, would that be acceptable? Does it fall between the two sides? Yes, it does. Let's just do 19 though. Sound good? Okay. 19.8 would work, but again, 19 also will work. Because we know then, basically, 19 could be basically pushed off that way a little bit, right? If I push it to the right a little bit, it could be 19. But also what could happen, again, 65 is not going to change, 20 is not going to change, but it could be tipped back this way and still be 19. So do you see there are two potential triangles? Which one should you solve first? The first one we did or the second one? I would solve the first one. Okay? So if you want to, if you don't like that 18.1 being in there, you can cross it off, or I can erase it if it's confusing you. Okay? To solve this, do we really have to worry about it? Not really, just do law signs. So sine of 65 over 19 equals sine of B over 20. Now let's face it, we expect this to actually be pretty close to 65. Okay, so go ahead and figure that out right now. You are going to need arc sign on this one, but I have faith that all of you can sign what we have written in black over there. And you may notice that I've drawn this the same way every time. I haven't altered the way I've drawn any of these. And how about angle B? Again, we're expecting something right around 65, but maybe just a little bit less. Well, actually, a little bit more, I'm sorry. 72.6, do we all agree with that? Okay. Now, what I would suggest you do, whenever you do these problems, maybe just circle that one, because that's the one that's going to be changed over here. And what the other class decided to do, and it's probably a good idea, is they just decided to finish the first triangle, then they're going to go back and do the other one. Probably not a bad idea, because otherwise you might forget where you were. So we know 65 has been used up. We know 72.6 has been used up. 42.4, I've been told, for angle C. Are there any disagreements with that? No? And we almost have the first triangle solved, but we're going to guess that side C here is going to be considerably less than the other ones, correct? And I normally, like I said, I go back to where I had my pair, and then I just erase that. And I say, all right, well, we got sine of 42.4 over c. So again, no arc sine needed on that one. And does anybody have side C figured out? Does 14.1 seem reasonable? Yeah, that seems within reason. Are there any questions how we solved the first one? This is the case where we have to go and find the other possible answer. And I unfortunately wrote 65 ginormous on that one. So 72.6. Well, give or take right about there, correct? And that's the triangle. You don't always have to draw the triangle in if you don't want. I'm just showing it to you so you see it. 72.6 is the first place that would give me that right ratio. And so again, what I do is figure out, well, how close am I to that y-axis? I'm pretty close this time. And how close am I? 17.4? Well, 90 is all the way to the y-axis. I took away the 72.6 that we've already used up. Okay. And that means you got to go 17.4 the other way, because those two triangles should look the same. They should have the same y value. And if you were already at 90, which is, again, that far, which is that, and you add 17.4, you're at 107.4. So that's what this angle is. That's another place. Again, if you take sine of 72.6 and sine of 107.4, I guarantee it gives you the exact same answer. And it happens to be the ratio of these sides. Okay. Now you can go ahead and find, here's angle A, angle B, go ahead and find angle C. I've been told 7.6. Well, that looks believable. And how about this side C on this one? I think we're going to agree that it's going to be less than the 14.1 we got on the other one. And if somebody could tell me that answer in the next couple minutes, that would be good. Is 2.7 believable? 2.7, 2.8? Yeah, 2.8. I think this is definitely believable, though, if you look at the sides. So again, if you were to give me the answer to this, you'd say, yeah, there's two solutions, and there they are.